Good morning, everybody. So my name is Daniel, CTO of Picnic, and we have a very simple mission. We want to make grocery shopping, to be precise, online grocery shopping, simple, fun, and affordable for everybody. So our mission started at a point where we were looking to what actually is a kind of a value proposition that would be interesting for customers. And for customers, that means, in essence, we want to deliver the groceries for free at lowest price to your doorstep, and if you like, even to your kitchen. And the proposition itself started at the point where we looked a little bit in the market, what actually is the reasons that online shopping for groceries is so low. So when we started in 2015, there was just 1%, 1.5% was online compared to the offline part of groceries. If you compare this to electronics, so electronics is 50, 60, books, fashion, is a large part is online. Groceries was nothing online. So there is a very simple reason for this, and there have been, in essence, kind of three reasons. Number one is grocery shopping is, in essence, relatively complex online. And I will show you a little bit what we did with data to make shopping much simpler. Second one is nobody wants to wait. So if you need to wait for your groceries, if you have a delivery window between 5 and 7, then this is not good enough, because maybe you want to eat at 6 and you don't know if actually your grocery is there or not there. And the third one is actually nobody wants to pay extra. So you want to have price parity to the offline alternative. So delivery fees is just not good enough. Before I go further into it, let me show a small video just to show in practice how a customer perceives Picnic. And then I show you three main cases how we are using data to make this happen. So that is the consumer proposition. So let's have a look behind the scenes, and let's look into three main challenges. First challenge is, how do you make shopping over a mobile application, so it's a mobile-only shop, really simple for groceries? Second one is, what should we offer to customers? What is the assortment? Relatively complex question. And the third one is actually, how do we deliver always on time in a very narrow window? So I will go in all three topics, but let me start with the first one. And the first is something what we call the mobile shopping challenge. And the mobile shopping challenge is something that you order your groceries, all kind of 30, 40 articles in a very short time. If you compare this to a typical online shop, like Amazon, like Bol, like Weekamp, then you just shop for 2 or 3 items, and you have much more inspirational or comparative shopping. So you look to the specification of an iPad, you look to the Android version, and to whatever kind of versions. With grocery shopping, the shopping cycle is completely different. You actually shop week over week for 80% exactly the same items. So therefore, we have been looking into how to make this experience much simpler, that you can shop in a short time with your mobile. So if you look into this, then actually the solution for this is that you offer or that you recommend not just single items, but bulk items. So that means 4, 8, or 12 items. And the idea there is that with a single tap, you actually can order then those items which actually cover already 20, 30, 50% of the entire basket. Such a feature can be only offered if you have a very high purchase confidence. So that means the items need to be relevant. So therefore, the challenges that you have in this kind of setup is if you have a precision system or a recommender system which has only 90% precision of an item, so that means 9 out of 10 items you recommend, then if you recommend 4 or 8 or 12 items in a batch, then for the batch of 12 items, you have only an accuracy of 28%. So it's 0.9 to 12. So that's obviously not good enough. You will not offer a feature to customers where only 1/3 of customers can use it and 2/3 cannot use it. So if you go the other way around, if you want to have a feature which is relevant for 0.9, so that means for 90% of your customers, you need to have a precision of 99%. So that is a complete different game that we are playing here compared to the traditional recommender systems. And then you have a couple of grocery-specific features that are seasonality, and these are event-based buyings that you cannot recommend or that you cannot easily predict. So let's look into what was our challenge here. Our challenge was that in the beginning when we started, we looked to the session time. And the session time is how long do you spend to actually finish your shopping trip. And when we started, we had a session time of around 400 seconds. And grocery shopping, one or the other way, is something what you need to do, but it's not the most fun. So therefore, we had the ambition to go down to around 200 seconds. So that means just halving the time. So how have we been doing this? We have been building a small model. So this is one of the models. Don't get scared too much about the mathematics. So we want to look into what is the probability that you buy the next time a milk, assuming that you have a shopping history that 4 days ago you have bought some Nutella, 7 days ago you have bought some Tony Chocoloni, and 9 days ago you have bought some Olives. So that's the simple mathematical formulation of what we have been doing. And the first step here is that you start with some AI. So this is, by the way, something what many companies do, and I will show you that this is not always the smartest way. So the model that you use is a so-called deep learning network called LSTM. So there's a long short-term memory. Without going too much into technical details, it means simply that you learn from your past shopping history, that you don't take so much into account what people have shopped in the very past, and you can also take some seasonality effects into account. So what you do is you take all the shopping history into account. So this is a kind of the input parameters on the left-hand side. Then you have hidden layers, where you try to understand what is actually the item-item relation. So what are people buying together as items? And then you look also to the item-day relation. So item-day relation, what do people buy on a Monday versus what people buy on a Friday? Very, very different. And then you try to recommend actually the output, what people buy tomorrow. Because if somebody shops today for tomorrow, then you want to recommend exactly those kind of items. So we have been doing this, and then we got a precision which was just and only 50%. So that's not good enough. And we try to understand what actually is the reason for this. And there have been technically 2 reasons. So the first one was that we had shallow data. So shallow data means per user, we didn't have sufficient history. So what we learned is that over time you need at least 30, 40, 50 orders to get really on a single user base a good recommendation. So there's something probably what most of you have also seen in different kind of recommender systems. You can get it a little bit lower if you take clusters of customers, but on a single customer level you need a large number of customers. Second challenge is you need a large training set. You need a lot of customers. That is something what we have now, but when we did the experiment a year back, that was not the case. So that is a big challenge for all those kind of recommender or AI-based systems. So we took this idea aside, and then we thought, well, you can certainly train the network and you do some pre-training, but let's look what people did already 10, 20 years back. And there's a very, very simple model which worked extremely well for us. And this is a model based on recency, frequency, and monetary. So this is a model that has been used by retailers for at least 20, 30 years. And this is super simple. Let me just talk you through. So you take the last 10 orders. So that means what everybody has bought the last 10 times. And if you have those, then you simply select those items that people have shopped for at least 8 of the 10 items. So it's relatively easy. Then you rank them by the frequency. So items that have bought more often, you rank on top, and the quantities, bigger quantities on top. Then you filter out everything what you don't offer any longer. So there's the seasonality effect, for instance, asperges and other products you don't sell over the whole year. And then you simply show the best items. That is a very, very simple algorithm. There's no big AI, but actually this algorithm leads to a very, very good recommendation. And what we did is we took this algorithm with the deep learning and then came up with the following model, or with the following insights. If you have actually not enough data. So that means if you have, what is the left-hand side? So if you have big data, lots of a big training set, but only very short order history, your precision will be low. On the other hand, if you look to the right, if you have deep data, so that means 10, 100 or 150 orders, not too many customers have this, but a few customers have this, then obviously you get also, for those customers, a high precision, but you have a very small set. So this is also not good. So the overall precision with such a model is not good enough. So you have here a sweet spot, which is called big and deep data, where you have actually the breadth of the data and the depth of the data is big enough to get precise and accurate recommendations. So this is something, putting it in a slightly different picture, that is kind of the sweet spot for all kind of deep learning algorithms is you need a lot of data. That's something what everybody talks about with big data, but you need also depth of data. I think not many people talking about this, but this is something which becomes more and more important, especially for recommender systems that are affected by seasonality effects, etc. So, first story. Second story, we call this the co-creation challenge. What we said is, we have around 4,000 articles, that is our base set, but this is not enough. A normal supermarket has a little bit more. We don't know exactly how many articles, or which additional articles we offer. Big retailers, what they do, they are asking research companies. So they're going to Nielsen or GfK, asking, okay, which additional articles should we offer in this city or that city? We thought we can do this much better or much simpler with data. What we do is we just ask our customers. And if a customer asks more than 3 times an article, then we just add it in. Very simple algorithm. So the first step is you just put in the app in a small feature where you say, okay, miss your eats, which means simply, do you miss something or would you like to have an additional product? And then you fill in the article. Then we put this in a system, and then there's a counting algorithm and then a communication around those kind of items. And then at some point, we add this product to our assortment if we have a sufficient request. And if not, then we will simply tell the customer that we are waiting for more demand on this. That works super well if you have just a couple of customers. Because then in the beginning, we had only 10, 15, 20 items per week. But as we were growing, this was going into hundreds and thousands of suggestions every single week. So at this point in time, you have a team of 10, 15 people which are just going through all the recommendations, trying to find out what are the kind of articles, and trying to count those articles. So this is obviously not scaling. What we thought is, let's use some AI. And in this case, it works very well. So what we do here is that now customers are actually giving feedback. So that means they are asking for an article, so for instance, organic pindakas from South France or whatever kind of products. Then we are putting this in our system, and the third step, this is the middle step, is the important one. We are putting this in Salesforce, but the really critical one is that we are using a machine learning engine from Azure in this case, but any other would also do, to actually try to link the customer feedback item to the actual product or the actual category that customer is asking for. So there are different kind of variations that customers are asking for this, but we are using an ML engine to actually do the link. So this works in a way that you do first kind of 10, 20, 30,000 recommendations. You manually tag, so that means you train your engine. And after you have done this, this works relatively accurate for most kind of articles. So let me show you a bit of results, what we have seen later. If you now look to the classification, we can now 70 to 80%, we can actually accurately classify. So if you look to a category, like for instance, a Vorratkast, so this is a typical cupboard, so typical daily items, there we have a classification which is more than 90%. And this is a pure linguistic classification. The ML engine that we are using has absolutely no understanding about the actual textual items. This is just training on what have customers asked in the past to the link to the actual product that we have been linking this to in the past. So that's a very, very successful one. On the other side, and this is a more the extreme one, is the one which is called a Dieren something. So that means animal food. So for animal food, there's not too much feedback. So obviously you don't have the depth of data. So you don't have enough data to train your system. And furthermore, it is also something where actually there is not too much variance in it. So that means people are asking either something which is completely out of the kind of the basic scope of a retailer, or it is in the scope, and therefore we are already offering this. So this is something where we have done a classification which is a little bit on a lower level. So this has helped us to bring the team which is doing the assortment classification from 10, 15 people to a much, much smaller group. So this has been definitely one of the success stories. So what you can learn here is that before you start an AI product, which we have not done as step 2, you need to do a proper analytics and proper data science as a kind of a first step to understand how do you set up the system and how do you actually calibrate the systems. So what we call this is that data science itself is the MVP of AI. So also if you look to something like Tesla, or if you look to a Snap, or if you look to Facebook, then none of those companies which are now very, very strong on the AI side have started with AI naturally. All of them have started with data science for the products that they have AIized as of now. Okay, third challenge is the distribution challenge. So distribution challenge means in our case that we want to deliver, that we deliver 99% on time, and that we are actually want to have a very high star rating for all kind of deliveries. And the really critical part is the on-time delivery. So a customer selects a relatively small window, and we deliver always on this small window. For us, the real critical part of this on-time delivery is the actual drop time. And why is this important? In the cities where we are already for half a year, or even longer, the actual drop time becomes even more important than the time between the drops. So drop times means how long do I spend with a customer to unload the vehicle, to bring it to the doorstep, to say a few friendly words, to go back to the vehicle. If you have a high density, and between two customers you just drive a few hundred meters, then this is something what you can do in a very short time. But the time you spend with the customer is valuable time, and you need to optimize, or you need to understand how much time do you need there. So the model that we built there is something where we calibrate the following formula. So first one, there's a kind of an area coefficient. So this coefficient just says, is this an area where you have a lot of one-way roads, or if you have very large buildings or small buildings, etc. And then the second one is we calibrate it to the specific number, how many times a customer has placed an order. If there's a first order, we spend a little bit more time with the customer. We just say a few friendly words, we help him to install the app, we help him if he has some other questions. So obviously this takes a bit more time. So in our case, this is 32 seconds that we take additionally in this case. Then the third one is how many totes, so this means how many products in the temperature zone ambient and chilled do we deliver to this customer. And then the third one is also how many products in the frozen zone. So that means kind of a frozen pizzas do we deliver to the customer. And then the really interesting part is actually how the additional parameters. We call this T delta, which is, for instance, do we deliver at daytime or do we deliver at night? If we deliver at night, then it takes an average 25 seconds longer. Do we deliver on the front door or do we deliver on the back door? Back door takes also around 20 seconds longer. Do we deliver first floor or fourth floor? That takes then also around 25 seconds longer. The interesting fact is, if you deliver on the second or the fourth floor, doesn't make a big difference. The real difference, first floor or higher. That's the real differentiating factor. And then there are a couple of more factors. So for instance, is this a runner which is a kind of new with us, or if he has already done some deliveries, obviously he knows a bit better the protocol. So based on this, the practical side of what the user sees now is that in the app he actually selects a delivery slot. So what you can see here now, the customer selects between 6:15 or 18:15 and 19:15. Then afterwards, we are refining this. So this is after the cutoff, we know the precise planning. So we can communicate to the customer, this is a 20-minute window. If you look now, 18:15, 19:10, very sharp window. And in this sharp window, actually, if we are on the road, then we will send a push notification to the customer. So this is a simple notification where we say, we are in a couple of minutes here. If you want to follow us, you can follow us. And here data plays another important role. What we do is actually we give the data back to customers in form of a small map where he can follow our driver. And that looks like the following. Let's see if the animation gets started. Maybe not. Okay, what you would see here is, this was an animation where you can actually see that the driver is going through the different kind of stops, and at some point you see actually exactly like an Uber that you're just 5 minutes, 4 minutes, 3 minutes away, and you can make a decision if you still go with the dog for a round or if you just open the door. The really interesting part is if you give this data to the customer, then customers help you to actually fulfill the delivery in a very efficient way. So customers opening the door, customers even help you potentially to unload your truck, etc. So this is something which we intended this just as a kind of a gamification feature, but it helps us also to deliver even more efficient to customers. So this is something what we have been doing as a kind of a third challenge from the distribution side. So that closes up my talk. The 3 challenges that we were solving with data were, number 1, what actually do we deliver to customers? So this is the assortment challenge. The second one was how do we offer this in a smart way? So this is the actual shopping challenge. And the third one is the distribution challenge. And that is one of the basic ingredients of the data strategy that we are doing in Picnic. Thanks for your attention.
Thank you, Daniel. Thank you for leaving some time for questions. I have one question. What about the driver? He can feel pushed to be somewhere in time. How does he get his feedback to leave a customer, to have talked enough to the customer? How does he get his feedback?
I think this is a very important point. So this is data that we collect internally, but that we don't deliver or that we don't expose directly to our drivers. Because we don't want that our drivers are pushed. We want that, say, deliver the best service to customers, that they take the time actually that it takes to a customer. What we want to understand is which driver, for which kind of customer, how long does it take? Because that is part of our planning model. But we don't want that he's in any way kind of pushed. And if it takes longer, then it takes longer. Customer service comes first.
Okay, thank you. Are there questions from the room? Yeah, there. Can you tell your name, please? I'll give you a microphone, that's easier.
Hello.
Hi.
My name is Michel, and I had a question about your second challenge, which was about categorizing the product suggestions. Because in your slide you showed how they were categorized in these main, categories.
Yeah.
But what then? I mean, you ideally want to have them categorized per individual product, right? Because not every kind of special pindakaas is the same special pindakaas.
Yes. The challenge that we are solving here is actually that if you're asking for a specific pindakaas, you have very different formulations. So you have, for instance, misspellings, but you have also that you write pindakaas out Frankrijk or pindakaas from whatever kind of stuff. And what you try to do with such a classification system is you take all different kind of ways to request a product and try to link it to the same product in the market. The assumption here is that somebody is asking for a product which we currently don't have in the assortment. So that means you need to have an entire catalog of all products that our retailers are offering. And then you build with such a recommendation or a linking engine, a link between the assortment feedback, so that means all the textual items, with the products that are meant. And that is something what you put as initially. You need to do 10, 15, 20,000 manual classifications. So this is a lot of work. But if you have done this, then what you will see is that the 20,000 first and 20,000 second way of asking for a specific type of product will be in essence exactly the same. So it's a little bit counterintuitive because the engine that we are using has very little NLP type of understanding, so this natural language processing. But it works well.
Okay, is that clear? Another question over here. Your name, please?
Hi, my name is Anneke. I was wondering, you started just in Amersfoort, very small. Yeah. At what point did you start with these data science solutions? Was that something that you did before going live in Amersfoort, or is it something that you only started doing when you started scaling up and scalability became a challenge?
Yeah. That is a very important point, and there's also very important learning. In essence, when we started in Amersfoort, we had just a MVP. So in essence, there was very little system support for all kind of data analysis or for any kind of smart data science. So we started just at a later point after we have been at least in 2 or 3 cities. So we started with this more or less 1 or 1.5 years ago when we had actually sufficient data. So that means a stable database from breadth and depth of data.
Okay, is that an answer to your one question I have, which is for me quite important? Do you have anything on inspiration of the buyer that he tries something else, or does he have to eat his whole life the same things?
That is a great question. Great question. So obviously, a recommender system is trying to extrapolate past behavior. That's a typical problem what all recommender systems have. So what we are now looking into is actually ways how we can help customers to maybe fulfill also life goals like eating more healthy or having a special diet, which we currently don't offer in the app. But obviously we are collecting data, and we have also the kind of data science in house that would allow us. So this is a very important topic that plays for us now also a role.
Okay. Are there any more questions? One maybe. Yeah, here at the front. Okay.
Erwin de Klein, hi. A question, I saw that you're collecting a lot of data, right? From customers, from orders. And in the chart you showed where you put the data, I saw Salesforce coming in.
Yeah.
As the CRM, I know it. Is that sufficient for the amount of data that you're going to collect when you go for the whole country, I mean, a lot of time?
Well, this is a bundled question. The first thing is we are collecting data that is actually, so we've started initially to collect all kind of data that we can get one or the other way. What we learned over time is it's more important that you collect the right data and that you get an understanding of the accuracy of data. For instance, for logistics data, where we actually calibrate our logistics model, you need to understand you cannot collect all data, or if you collect all data, you need to understand the variance of the data. So therefore, we are kicking out roughly half of the data that we're collecting because it's not accurate enough. If you're asking for the scalability of Salesforce, obviously we are not putting all the analytics data we have in our own data warehouse, so we are not putting this through Salesforce. Salesforce is for us more kind of a CRM system where we manage kind of the catalog and the pricing and etc.
Okay, at the end, the right data came up.
Exactly.
Okay.